Hi, these are the answers to the related rates worksheet. First one has a 15-foot ladder leaning against the wall. So we're going to draw a picture of that. 15-foot ladder leaning up against the wall. It says the top of the ladder slides down the wall at a rate of 2 feet per second. So we're coming down at a rate of 2 feet per second. Okay? And we're asking how fast is the bottom of the ladder moving. So we want to know how fast that's traveling when the ladder is 12 feet from the wall. So when this distance is 12 feet. So we can do a little Pythagorean theorem to try to find this side, which we probably will need eventually. Or we can do a Pythagorean triple. If you remember, a 3, 4, 5 is a Pythagorean triple. This really is just that, but multiplied by 3. So in other words, if I make this 9 feet, 9, 12, 15 is in the same ratio as 3, 4, 5. But you could do Pythagorean theorem off to the side and find that that's 9 as well. All right. Now we need the Pythagorean theorem anyway. So we'll call this side here x. We'll call this side y. And the ladder is not a variable. It's a constant 15. So x squared plus y squared is equal to 15 squared. All right. And if we take the derivative, we get 2x times dx dt plus 2y times dy dt equals the derivative of a constant, which is 0. Okay. X is going to be this length, which we found to be 9. So 2 times 9 times how that's changing, which is 2 feet per second. But it is shrinking at 2 feet per second, right? So really it's a -2. And you probably could get there if you had made that +2. You probably could understand, the relationship here. But it's not a direction. It's really a description of whether this length is getting bigger or smaller. And since it's getting smaller, that's why we make it negative, right? Y is 12, and dy dt is what we're trying to find. Okay, so if we do this, this is 36, -36. If we add that over, we're going to get 24 dy dt equals 36. And if we divide, we get dy dt equal to 1.5. 1.5 foot per second. That's how fast the bottom is moving out. All right. Number 2. We got a stone dropped into a pond, creates still ripples. The radius of one of these increases at a rate of 2 feet per second. 2 feet per second is the change in radius with respect to change in time. Okay, 2 feet per second. How fast is the area changing? So what we're looking for is dA dt. Okay, so we need an equation that relates area and radius. That's easy enough. The area of a circle is pi times radius squared. So when we take the derivative, dA dt will equal 2 times pi times radius times dr dt. So we took pi as a constant, brought the 2 down, subtracted 1, left the inside alone, then times the derivative of the inside, which gives us that. Okay. We are told that the radius is 12, and we were told that dr dt was 2. So if we put that information in, then dA dt will be 2 times pi times the radius 12 times dr dt. Which gives us 48 pi, and since it's an area, it'll be square feet per second. Okay, and if you wanted to multiply that out, you can, but that's what we get there. Now, in the second one, it says if the area is changing at a constant rate of 24 square feet per second, so this is change in area over change in time, how fast is the radius changing? So we're looking for dr dt. When the area is 130. So now we're told the area is 130. So there's a little work that we have to do. We have to take that same area formula, pi r squared, but this time we're going to have to put 130 in and solve for the radius. Okay, so not a big deal. We're going to go 130 divided by pi, and then we're going to take the square root of that. And that's going to give us a radius of 6.43275 098. Now, I don't like to round an intermediate number, meaning that this is not our final answer, right? This is what we're going to use to get to our final answer. So I like to keep that as big as I can. If I can keep it on the calculator, maybe store it into something and then use it, that's a good idea. But you don't necessarily want to round right now. You want to round later on, okay? So that's our radius. We have our equation from before, dA dt is equal to 2 pi r dr dt. And what we know right now is dA dt was 24. So 24 equals 2 times pi times the radius, which is 6.4327509.8 times dr dt. All right. So what I'm going to do on the calculator is I'm going to go 24 divided by parenthesis 2 pi, and then I'm going to hit answer because answer has my thing on there. If you can kind of look and see that 6.4327, that was my previous answer. So if I just go second negative sign to get answer, then it will include that on there. So now I'm doing 24 divided by all of this, and we get our answer of 0.594. dr dt is 0.594, and it'll be feet per second. So that's page 1 of the related rates worksheet.